This video is going to be for Design and Communication Graphics, PN 4025 for week 6. The topic we're going to be dealing with is axonometric and perspective projection. These all fall underneath the categories of pictorial projection. As you can see here, there's 3 different sections to pictorial projection. You have oblique projection, axonometric projection, and perspective projection. Like I said previously, the topics we're going to be dealing with in this lab will be axonometric projection and perspective projection. Oblique projection would be a part of your primary school curriculum, your junior cert curriculum, and it was elaborated on throughout your first year graphics modules. We'll just have a quick look back over it. So this is oblique projection. Very simple. There's 2 different types, cabinet and cavalier. You can also see here the way in which you can draw it, and you can also see examples of it being carried out to, I suppose, represent different objects. Now, this is a nice simple one. We don't have to worry about this, so we can move on to our second, which is axonometric projection. Now, for axonometric projection, there is 3 subcategories or 3 different sections that can be broken down into, which would be isometric, diametric, and trimetric. Now, the difference between all these is just the angle at which you look at the object itself. Now, you more likely have heard of these before, especially isometric would be the most common one people use, but you would have also seen them while using SolidWorks. So if you're in SolidWorks and you ever want to change the view at which you look at your object, you can actually have a drop-down menu where you can click the front plane, back plane, left plane, right plane, or top plane or bottom plane. As well as that, they also have an addition that you can click on isometric, trimetric, or diametric. That's a good way to show, I suppose, off the different views themselves, and a lot of you will have come into contact with them previously. So firstly, before we break down the 3 different types, I want to talk about the axonometric plane. Now, all the terminology I'm going to talk about here can be applied to any one of the 3 when completing the drawings. So first of all, I want to identify the axonometric plane itself. So you can see it's this yellow section as well as the yellow section outside here. The reason why there's a bit of a gap is because it's actually cutting through this plane's reference, as you can see. And to identify the place that's cutting through, you have your traces. You can see your traces here. Now, each one of the traces actually add up to make your trace triangle. Then with your plane's reference, you have your vertical plane, your invertical plane, and your horizontal plane. In addition to that, then you also have the triangle that is made from your traces, which, depending on the type of axonometric projection that you're completing, if it's isometric, diametric, or trimetric, that shape will change. Additionally to that, I want you to take note of the 3 different axes that are talked about when completing these types of drawings, which is your y-axis, your z-axis, and your x-axis, as you can see here. And they're all traveling from the central point here where the 3 planes meet. So we'll have a first look at isometric projection, which is the simplest of the 3. Isometric projection, as you can see here, the y-axis remains vertical, so the y-axis here stays vertical. All 3 distances are equal, so you can see the distances for each one of the axes all the ways out, as you can see here, like D, D1, and D2 are all the same. And the 3 angles between the axes are equal, so the angle between Z, Y, Y and X and Z are all 120 degrees. That is what makes it isometric. Additional to that, the trace triangle is an equilateral triangle. Okay, so as you can see here, it's an equilateral triangle. Now, if we move on and have a look at diametric, the y-axis remains vertical as well. The 2 angles have remained equal. So only 2 angles this time remain equal. So as you can see that in the image here, we can see the XY angle and the YZ angle remain the same, while the 3rd angle from X to Z is not the same. So instead of the 3 for isometric, for diametric, there's only 2 that remains the same. Traces form an isosceles triangle, as you can see here. Also note how the X, Y, and Z axis are extruding and they intersect the traces perpendicularly. Okay, so As you can see here, the z-axis, as it continues on, as you can see the dashed lines here, where it hits the trace itself, it is perpendicular. The same with the x-axis as it travels down, it's also perpendicular, and the y-axis as it travels down here, it's also perpendicular. That's important to note. Now if we look at trimetric, the y-axis remains vertical like the other two, but for this one the angles between the y, z and x-axis are all different. So each one of these angles are different. The traces produce an isosceles, a scalene triangle where none of the angles are equal. Now if we move on, another bit of terminology that you'll need to know, as you can see here, when we are completing these drawings, which you will become more familiar with after you watch my example video of completing one, or even have a look at the graphics books, you'll see that this construction is completed. Now as you can see, the triangle of center has to do with the trace triangle, as well as that on the left, right and the bottom you have basically your different views being projected. So you can imagine for your vertical plane you'd have your elevation of your object, your end vertical plane would have your end view, and your horizontal plane like usual would have your plan. Now you can see this above here where you have your object that would be in either isometric, diametric or trimetric. By the look of this, it's in isometric, and as you can see here on the left hand side, just as it is below, this would be the end view, and as you can see above here would be the elevation. Now to find your central image here, your isometric, what you'll need to do is construct basically what you can see below here, which I'll travel through in my example. Put in your elevation, put in your end view, and put in your plan, and then using that you'll be able to construct this isometric, diametric or trimetric view. Now here's the example, and that is then completed in this drafting video that you can watch in your own time. Now see if we can click onto the next slide. Give it a few seconds. Okay, we jump back out of that. So as you can see here, this is the completed drawing itself. You can have a look at that afterwards, after watching the video, and then that might be able to help you work your way through your own drawing, as well as that if you want to go back and complete this drawing just for, I suppose, a bit of study in relation to completing these types of drawings, or just practice, by all means you can work away. Now we're going to move on to our last type, which is pictorial projection. Now for pictorial projection, it's different again, and there's a few bits of key terminology that you'll need to learn before we run through an example of how to complete it. What I've done here is I've taken images that someone else has created on the T4 website to help explain, I suppose, all the key bits of terminology that you'll need to know before completing the task itself or watching even my example video. As well as that, these models that have been provided on the T4 website I find extremely beneficial in explaining what is actually happening in this drafted drawing itself. Now it's not a tough drawing to actually complete, but it's tough to actually understand what is going on. So as you can see here, we have our different bits of terminology. So we have, you know, the object itself back here. We also have the spectator, which is at the very point here. So it's, imagine the eye of the spectator, what they're seeing. You have your ground plane, which is back here. So the plane in which the spectator is standing, the plane of the object to be drawn lies on it. As well as that, then you have your picture plane, and your ground line, and your spectator. So you have your spectator here, and you have your ground line there, which is just above your ground plane. The ground plane would be this grey section here. Now, as well as that, you have your cone of vision. So from your spectator, his cone of vision is what he can see. And you can see the object there, how it's distorted. It's actually in that perspective view because of how he is looking at the object and as it is projected onto this plane itself. As well as that, you have your horizon line, which you can see here in blue, which has your VP1 and your VP2, which are two different vanishing points. As well as that, you have your sight lines, so you can see all the different lines that are traveling through the different corners. For example, if we look at the spectator here and follow this line along, that's traveling through the bottom front left hand corner here, which travels all the way through to the object, but you can see that it is just cut off here at the plane itself, as well as the one traveling towards the back corner and towards each corner of the object, creating this perspective view of the object itself. And this is what we will be completing in the drawing. And this is just another image of what's happening, so you get a bit of an idea of where all the different points are coming from, as well as these vanishing points. It's also important to remember that these lines here are parallel lines that are meeting it at infinity. So that VP1, that VP2 is actually a point at which two parallel lines are converging, which is infinity. So that's why in perspective parallel lines seem like they're converging. Here's the example that I run through. It's a good bit tougher than the actual one you have to complete for the lab. I'm hoping that then it can be a good example for you to look back on and help you support yourself when completing questions like this in the future. And then I have the drafted video which goes through how it's completed. And then I've also included here is the finished drafted drawing itself. As well as that, now you have your lab activity 1, which is basically completing the first type of projection drawing I want you to complete, and then covering the second type of projective drawing that we were basically traveling through there as well. Now for each one of these, the solution is provided within the David Anderson's graphics book. 100% go back, have a look at that, use that to help you put these drawings together. Remember, these are leaving cert cycle subjects. It's 5th and 6th year students are finishing these, and they usually complete 2 to 3 drawings within a double class. So by all means, take your time, look back at the book. They're not rocket science. It just takes a while for you to get used to the construction, especially if it's your first time traveling through it. Just take your time watching my videos, get to know the terminology, and try to wrap your head around what's happening. After that, have a look at your checklist. Ensure that you have everything completed for this week's lab and tutorial, and submit it by the end of the week. So as you can see here, you're going to have your 2 different lab activities, and this week we're going to have a principal sheet covering these 2 topics because they're not quite like any other topic that we've covered before, even though a few principles do come across, but the constructions to lay them out are unique in themselves. As well as that, like always, if you need additional support, if you're having trouble completing one of these drawings or one of the activities, be sure and send me an email. If I can help, I will do. If it means we'll have to meet up on Skype and share your screen and see what you're at, I'd be more than willing to do so.